In this video, we are going to discuss about solving advanced, nested, double, triple, and quadratic absolute value equations. 1. Solve absolute value of absolute value 2x minus 1 minus 2 is equal to 6. This is nested absolute value equation. We use the definition of absolute value of x to solve this nested absolute value equation. Absolute value of x is equal to a implies x is equal to a or x is equal to minus a. So this is equal to absolute value of 2x minus 1 minus 2 is equal to 6, or absolute value of 2x minus 1 minus 2 is equal to minus 6. So when we take minus 2 to the right, it becomes 6 plus 2, which is equal to 8. And when we bring this minus 2 to the right, it becomes minus 6 plus 2, which is equal to minus 4. This has no solution. Why? Because since the output of absolute value can't be negative, whereas this one is, so 2x minus 1 is equal to 8, or 2x minus 1 is equal to minus 8. Then bring minus 1 to the right, it becomes 8 plus 1 is equal to 9. 2x is equal to 9. When we divide by 2, we get x is equal to 9 over 2. When we bring minus 1 to the right, we get minus 8 plus 1 equal to minus 7. When we divide by 2 both sides, we get the values of x is equal to minus 7 over 2. So the solution set is minus 7 over 2 and 9 over 2. To solve absolute value of absolute value 3x minus 2 plus 3 is equals to 5. This is nested absolute value equation. So to solve this, we use the definition of absolute value. Absolute value of 3x minus 2 plus 3 is equal to 5, or absolute value of 3x minus 2 plus 3 is equal to minus 5. When we bring this 3 to the right, it becomes 5 minus 3, which is equal to 2. And when we bring this 3 to the right, minus 5 minus 3, which is minus 8. But this one has no solution because the output of absolute value can't be negative. 3x minus 2 is equal to 2, or 3x minus 2 is equal to minus 2. When we bring minus 2 to the right, we get 2 plus 2, which is equal to 4. So 3x is equal to 4. When we divide both sides by 3, we get 4 over 3. When we bring minus 2 to the right, minus 2 plus 2 becomes 0. And when we divide both sides by 3, we get x is equal to 0. So the solution set is 0 and 4 over 3. Welcome to my YouTube channel. I'm Gazahay. If you are new to the channel, please subscribe to get more video and hit the bell icon to get all notification. Please watch full video. Let's continue. 3. Solve absolute value of 2x plus 1 plus absolute value of x minus 2 is equal to 4. This is double absolute value equation. To solve this double absolute value equation, we use the definition of absolute value. Absolute value of x is equal to x if x greater than or equal to 0 minus x if x less than 0. Absolute value of 2x plus 1 is equal to 2x plus 1 if 2x plus 1 greater than or equal to 0, and minus of 2x plus 1 if 2x plus 1 less than 0. And when we solve for x, we get absolute value of 2x plus 1 is equal to 2x plus 1 if x greater than or equal to minus 1 over 2. And when we multiply by negative, we get minus 2x minus 1 if x less than minus 1 over 2. Absolute value of x minus 2 is equal to x minus 2 if x minus 2 greater than or equal to 0, and minus of x minus 2 if x minus 2 less than 0. And when we solve for x, absolute value of x minus 2 is equal to x minus 2 if x greater than or equal to 2 minus x plus 2 if x less than 2. So we have 3 cases to solve this double absolute value equation. Case 1, below minus 1 over 2. Case 2, between minus 1 over 2 and 2. Case 3, above 2. When x is less than minus 1 over 2, the output of absolute value of 2x plus 1 is minus 2x minus 1. Here is we write minus 2x minus 1. When x is greater than or equal to minus 1 over 2, absolute value of 2x plus 1 is 2x plus 1. Here we write 2x plus 1, 2x plus 1. X is less than minus 1 over 2. Since it is only less than, so in this interval minus 1 over 2 is not included, whereas in this interval, since it has greater than or equal to, so in this interval minus 1 over 2 is included. Since it's greater than or equal to 2, so 2 is included here on this interval. When x is greater than or equal to 2, absolute value of x minus 2 is x minus 2. So we write here x minus 2. When x is less than 2, absolute value of x minus 2 is equal to minus x plus 2. Here we write minus x plus 2 minus x plus 2. For case 1, simply we add. Here is addition. Absolute value of 2x plus 1 is minus 2x plus 1. Absolute value of x minus 2 is minus x plus 2. Simply we add this and make is equal to 4. So this this become, so when we add minus 3x plus 1 is equal to 4. When we bring 1 to the right, we get 4 minus 1. Then divide by minus 3, we get x is equal to minus 1. Since this minus 1 is an element of this interval, so minus 1 is a solution. When we come to case 2, simply add vertically minus 2x minus x, we get x. 1 plus 2, 3 is equal to 4. When we bring 3 to the right, 4 minus 3 is equal to 1. So the values of x is equal to 1. Is 1 an element of this interval? Yes. So 1 is our solution. When we come to case 3, so when we add vertically, we get 2x plus x is equal to 3x. 1 minus 2, we get minus 1 is equal to 4. When we bring 1 to the right, we get 4 plus 1, which is equal to 5. Then divide by 3 both sides, so you will get x is equal to 5 over 3. Is 5 over 3 an element of this interval? Yes. So it is a solution. So our solution set is minus 1, 1, and 5 over 3. 4. Solve absolute value of 4x minus 1 minus absolute value of minus 2x plus 3 is equal to 8. This is a double absolute value equation. Absolute value of 4x minus 1 is equal to 4x minus 1 if 4x minus 1 greater than or equal to 0. Minus of 4x minus 1 if 4x minus 1 less than 0. When we solve 4x, we get, when we bring 1 to the right, we get positive 1. Then divide by 4, we get x greater than or equal to 1 over 4. And when we solve it again, we get x less than 1 over 4. Absolute value of minus 2x plus 3 is equal to minus 2x plus 3 if minus 2x plus 3 greater than or equal to 0. Minus of minus 2x plus 3 if minus 2x plus 3 less than 0. When we solve 4x, when we bring 3 to the right, it become minus. Then minus 2x greater than or equal to minus 3 we get. And we divide both side by negative 2. So when we divide by negative 2, the inequality will be changed. So this greater than or equal to will be changed to less than or equal to 3 over 2. And the second one is negative times negative, we get positive 2x. Negative times positive 3, we get minus 3. When we bring 3 to the right, it becomes negative 3. Then when we divide by negative, the inequality will be changed. So this less than will be changed to greater than. Absolute value of minus 2x plus 3 is equal to 2x minus 3 if x greater than 3 over 2. The smallest number is 1 over 4. So we write 1 over 4 first, then second 3 over 2. So case 1 is below 1 over 4. It doesn't include 1 over 4 because here is less than only. And the second case is between 1 over 4 and 3 over 2. It includes both 1 over 4 and 3 over 2 because here is the inequality is greater than or equal to. It includes 3 over 2 because equal sign here. And the third case is it doesn't include 3 over 2 because here is only greater than or there is no equal sign. When x is less than 1 over 4, this absolute value, the output of this absolute value is minus 4x plus 1. Here we write minus 4x plus 1. When x greater than 1, greater than or equal to 1 over 4, absolute value of 4x minus 1 is 4x minus 1. So we write here 4x minus 1, 4x minus 1. Okay, when x is greater than 3 over 2, the absolute value of minus 2x plus 3 is 2x minus 3. Here is we write 2x minus 3. When x is less than or equal to 3 over 2, absolute value of minus 2x plus 3 is minus 2x plus 3. Here on this interval, x is less than 3 over 2. So we write minus 2x plus 3 minus 2x plus 3. For case 1, so this value is minus 4x plus 1 minus this value is minus 2x plus 3 is equal to 8. So when we rearrange, we get minus 4x minus of minus 2x is plus 2x. Minus 4x plus 2x is we get minus 2x. 1 minus 3 is we get minus 2. When we bring minus 2 to the right, we get 8 plus 2. This 8 plus 2 is 10. Then divide by negative 2. Both sides we get the values of x is equal to minus 5. Is minus 5 an element of this interval? Yes. So minus 5 is our solution. Case 2, 4x minus 1 minus the output of this absolute value is minus of negative 2x plus 3 is equal to 8. Negative of negative 2x is positive 2x. Positive 2x plus 4x is 6x. Minus 1 minus 3 is minus 4. When we bring to the right, we get plus 4. 8 plus 4 is 12. When we divide both sides by 6, we get x is equal to 2. But 2 is not a member of this interval. 2 is not a solution for this equation. Case 3, the output of this absolute value is 4x minus 1 minus the output of this absolute value is 2x minus 3 is equal to 8. 4x minus 2x is 2x, minus 1 minus of minus 3 is plus 3. It becomes 2. When we bring it to the right 2, we get 8 minus 2. 8 minus 2 is 6. When we divide both sides by 2, 6 over 2 is equal to 3. 3 is a member of this interval. X is equal to 3 is a solution. Therefore, the solution set is minus 5 and 3. 5. Solve 2 absolute value of 3x minus 4 minus 3 times absolute value of 2x minus 6 is equal to 10. This is also a double absolute value equation. Absolute value of 3x minus 4 is equal to 3x minus 4 if 3x minus 4 greater than or equal to 0. When we solve for x, we get 3x minus 4 if x greater than or equal to 4 over 3 and minus 3x plus 4 if x less than 4 over 3. Absolute value of 2x minus 6 is equal to 2x minus 6 if 2x minus 6 greater than or equal to 0 and minus of 2x minus 6 if 2x minus 6 less than 0. When we solve for x, we get 2x minus 6 if x greater than or equal to 3 and minus 2x plus 6 if x less than 3. So we write first the smallest number. So the smallest number is 4 over 3. Then we write 3. Case 1 is below 4 over 3. It doesn't include 4 over 3. Why? Because here is less than. Case 2, between 4 over 3 and 3, it includes 4 over 3 because here is greater than or equal to sign. Case 3, greater than or equal to 3. It includes 3. Why? Because here is equal sign on the inequality. When x is less than 4 over 3, the output of this absolute value is minus 3x plus 4. Here we write minus 3x plus 4. And when x is greater than or equal to 4 over 3, the absolute value of this 3x minus 4 is 3x minus 4. So we write here 3x minus 4, 3x minus 4. When x is greater than or equal to 3, absolute value of 2x minus 6 is 2x minus 6. Here we write 2x minus 6. Here on this interval x is less than 3. On this interval also x less than 3. So absolute value of 2x minus 6 is minus 2x plus 6 when x is less than 3. So we write here minus 2x plus 6 and minus 2x plus 6 here. So for case 1, 2 times minus 3x plus 4 minus 3 times minus 2x plus 6 equal to 10 minus 6x plus 8. This one is positive 6x minus 18 is equal to 10. This minus 6x plus 6x will be cancelled out. 8 minus 18 is minus 10 is equal to 10, which is false. On this case has no solution. Case 2, then when we multiply by 2 this, we get 6x minus 8. When we multiply by 3 this one, minus 3 times minus 2, positive 6x minus 3 times 6 minus 18 is equal to 10. 6x plus 6x is equal to 12x. Minus 8 minus 18 is minus 26. When we bring to the right, 10 plus 26. So we get 12x is equal to 36. When we divide by 12 both sides, we get the values of x is equal to 3. But this 3 is not a member of, this interval. So on this case has no solution. Case 3, 2 times absolute value of 3x minus 4 is 3x minus 4 minus 3 times absolute value of 2x minus 6 is 2x minus 6 for this case. Then multiply 3x minus 4 by 2, we get 6x minus 8. Then multiply 2x minus 6 by minus 3, we get minus 6x plus 18 is equal to 10. 6x minus 6x will be cancelled out. Minus 8 plus 18 is 10 is equal to 10, which is true. All interval of this case is a solution. So any value on this interval satisfies this double absolute value equations. So the solution set is the set of x is that x greater than or equal to 3. 6. Solve 2 times absolute value of minus 3x plus 6 minus 4 times absolute value of 5x plus 10 is equal to 12. This is double absolute value equation. Absolute value of minus 3x plus 6 is equal to minus 3x plus 6 if minus 3x plus 6 greater than or equal to 0. Minus of minus 3x plus 6 if minus 3x plus 6 less than 0. When we solve for x, we get minus 3x plus 6 if x less than or equal to 2. Why? This inequality will be changed. When we bring 6 to the right, we get minus 6. Then when we divide by minus 3, the inequality will be changed from greater than or equal to 2, less than. So when we divide minus 6 by minus 3, we get x less than or equal to 2. Absolute value of minus 3x plus 6 is equal to 3x minus 6 if x greater than 2. When we bring 6 to the right, it becomes minus 6. Then when we divide by negative 3, both sides, the inequality less than than will be changed to greater than. Absolute value of 5x plus 10 is equals to 5x plus 10 if 5x plus 10 greater than or equal to 0, minus of 5x plus 10 if 5x plus 10 less than 0. And when we solve for x, we get x greater than or equal to minus 2, x less than minus 2. The inequality is not changed because there is no division by negative. And the smallest number is negative 2, so we write the smallest number first, then we write the next number here. So we have three cases, case 1, case 2, case 3. So for case 1, below minus 2, it doesn't include minus 2. Why? Below minus 2, there is less than only, there is no equal sign here. And for case 2, close interval minus 2, 2. Why we make close interval minus 2 here? Here is greater than or equal to sign. Why we make close interval on 2? Here is 2 is less than or equal to 2, is there is equal sign here. Why we make here is open? Because there is only greater than sign, there is no equal sign. When x is greater than 2, absolute value of minus x plus 6 is 3x minus 6. Here we write 3x minus 6. And when x is less than or equal to 2, absolute value of minus x plus 6 is minus 3x plus 6. So we write minus 3x plus 6 minus 3x plus 6 here. When x is less than minus 2, absolute value of 5x plus 10 is minus 5x minus 10. Here we write minus 5x plus 10 when x is less than minus 2. When x is greater than or equal to minus 2, absolute value of 5x plus 10 is 5x plus 10. Here we write 5x plus 10, 5x plus 10 on both interval because on this interval x is greater than minus 2. So for case 1, 2 times absolute value of minus 3x plus 6 is minus 3x plus 6. Here we insert 2 times minus 3x plus 6 minus 4 times absolute value of 5x plus 10 for case 1 is minus 5x minus 10 is equals to 12. When we multiply by 2, we get 2 times minus 3 minus 6x, 2 times 6, 12 plus minus 4 times minus 5, 20x plus minus 4 times minus 10, 40 is equals to 12. This 12 will be cancelled out. Minus 6x plus 20x is equal to 14x is equal to, when we bring 40 to the right, we get minus 40. So the values of x is equal to, when we divide by 14 both sides, the values of x is equal to minus 20 over 7. Minus 20 over 7 is a member of this interval, so minus 20 over 7 is a solution. Case 2, 2 times absolute value of minus 3x plus 6. The output of this absolute value is minus 3x plus 6 minus 4 times absolute value of 5x plus 10 is 5x plus 10, which is equal to 12. Then multiply minus 3x plus 6 by 2, we get minus 6x plus 12. When we multiply 5x plus 10 by minus 4, we get minus 20x minus 40 is equal to 12. This 12 will be cancelled out. Minus 6x minus 20x, we get minus 26x. When we bring negative 40 to the right, we get positive 40. When we divide both sides by negative 26, we get 40 over minus 26. So when we simplify, we get x is equal to minus 20 over 30. Minus 20 over 30 is a member of this interval. So minus 20 over 30 is a solution. Case 3, 2 times absolute value of minus 3x plus 6 is, the output of absolute value of minus 3x plus 6 is 3x minus 6 minus 4 times absolute value of 5x plus 10 is, the output of this absolute value is 5x plus 10 is equal to 12. Then multiply 3x minus 6 by 2, we get 6x minus 12. Multiply 5x plus 10 by minus 4, we get minus 20x minus 40 is equal to 12. 6x minus 20x is minus 14x. When we move minus 12 minus 40 to the right, and when we add with 12, we get 64. Then divide both sides by negative 14 and simplify, we get x is equal to minus 32 over 7. This is not a member of this interval. That's why this is not a solution for this double absolute value equation. So the solution set is minus 20 over 7 and minus 20 over 13. 7. Solve absolute value of x minus 2 plus absolute value of x plus 3 plus absolute value of x minus 5 is equal to 10. This is triple absolute value equation. We solve this similar to the double absolute value equation, but it has 4 cases. So absolute value of x minus 2 is equal to x minus 2 if x greater than or equal to 2, minus x plus 2 if x less than 2. Absolute value of x plus 3 is equal to x plus 3 if x greater than or equal to minus 3, minus x minus 3 if x less than minus 3. And absolute value of x minus 5 is equal to x minus 5 if x greater than or equal to 5, minus x plus 5 if x less than 5. So we have 4 cases. So the case 1 is below minus 3. Why we make open interval? Because it has only less than sign. Case 2, between minus 3 and 2. It includes minus 3. Why? The inequality is greater than or equal to sign here. Why we make 2 open? Here is only less than sign. And the third case is why we make 2 is closed interval. The inequality at 2 is greater than or equal to 2 has equal sign. And 5 is open. Why we make 5 is open? Here only less than sign. And case 4, here there is equal sign. That's why we make 5 is closed for this case. Now let's write the output of the absolute value when x is greater than or equal to 2 for both these 2 cases. X is greater than or equal to 2. So we write this one x minus 2. Here x minus 2, x minus 2. For both these 2 cases, x is less than 2. So we write minus x plus 2. When x is greater than or equal to minus 3, for these 3 cases, x is greater than minus 3. So we write x plus 3, x plus 3, x plus 3 here. For this case, x is less than minus 3. So when x is less than minus 3, the output of this absolute value is minus x minus 3. Minus x minus 3 here. When x is greater than or equal to 5, the output is x minus 5. So we write here x minus 5. When x is less than 5, so for these 3 cases, x is less than 5. So we write this output minus x plus 5 here. Minus x plus 5, minus x plus 5, minus x plus 5. Here plus plus. Simply add vertically and make is equal to 10. So for case 1, add vertically. We get minus x minus x minus x minus 3x. 2 minus 3 plus 5, we get 4. Minus 3x plus 4 is equal to 10. When we bring 4 to the right, 10 minus 4 is 6. Then divide by minus 3 both sides, we get x is equal to minus 2. But minus 2 is not a member of this interval. So minus 2 is not a solution. For case 2, add vertically. You get minus x plus 10 is equal to 10. Then divide by negative 1 both sides, you will get x is equal to 0. Since 0 is a member of this interval, so 0 is a solution. Case 3, when we add vertically, we get x plus 6 is equal to 10. When we bring 6 to the right, 10 minus 6 is equal to 4. So the values of x is equal to 4. Since 4 is a member of this interval, so 4 is a solution. Case 4, add vertically, we get 3x minus 4 is equal to 10. When we bring minus 4 to the right, it becomes 14. Then divide by 3, x is equal to 14 over 3. But 14 over 3 is not a member of this interval. So 14 over 3 is not a solution. So the solution set is 0 and 4. 8. 3x squared is equal to minus 16 absolute value of x plus 35. This is quadratic absolute value equations. 3 times absolute value of x squared plus 16 absolute value of x minus 35 is equal to 0. Since x squared is equal to absolute value of x squared is equal to absolute values of x the whole square. These 3 things are equal. So we can write x squared in the form of absolute value of x squared. And let t is equal to absolute values of x. Then when we write this, 3t squared plus 16t minus 35 is equal to 0. Now this is a quadratic equation. So we can solve either factorization, completing the square method, or general quadratic formula. I solve by factorization method. We must find 2 numbers. The sum is 60 and the product is 3 times minus 35, which is equal to minus 105. So the numbers are minus 5 and 21. Then insert 3t squared plus 21t minus 5t minus 35 is equal to 0. Then group these 2 and take the common. So the common for these 2 is 3t. So what left? T plus 7. The common for these 2 is minus 5. So what left? T plus 7. T plus 7 when we take as common, we left 3t minus 5 is equal to 0. And when we solve this, t plus 7 is equal to 0 or 3t minus 5 is equal to 0. So the values of t is equal to minus 7 or t is equal to 5 over 3. But since t is, we have assigned absolute values of x. So absolute values of x is equal to minus 7 or absolute values of x is equal to 5 over 3. But the output of absolute value can't be negative. So for this case, has no solution. But for this one, absolute values of x is equal to 5 over 3 implies x is equal to 5 over 3 or x is equal to minus 5 over 3. So the solution set is minus 5 over 3 and 5 over 3. 9. Solve minus 3x squared plus 16x is equal to 6 times absolute values of x minus 13. This is quadratic absolute value equation. So to solve this, we must write in standard form of quadratic equation. Let us assign absolute values of x by t. So it becomes minus 3t squared plus 10t plus 13 is equal to 0. Now this is a quadratic equation. equation. So I have solved by factorization method. We need two numbers. The sum is 10 and the product is minus 3 times 13, which is equal to minus 39. So these two numbers are minus 3 and 13. So this become minus 3t square minus 3t plus 13t plus 13 is equal to 0. Then group these two and take out the common. So the common for these two is minus 3t. What left? T plus 1. And the common for these two is 13. So what left? T plus 1. So we can take out as a common t plus 1. So what left here? Minus 3t. What left here? 13. Product is equal to 0 when t plus 1 is equal to 0, or minus 3t plus 13 is equal to 0. And when we solve for t, when we bring 1 to the right, we get minus 1. When we bring 13 to the right and when we divide by minus 3, we get negative 13 over negative 3, which is equal to 13 over 3. Since t is absolute values of x, so absolute values of x is equal to minus 1 has no solution because the output of absolute value can't be negative. Absolute values of x is equal to 13 over 3 implies x is equal to 13 over 3 or x is equal to minus 13 over 3. So the solution set is minus 13 over 3 and 13 over 3. 10. Solve minus 5x squared plus 2 times absolute values of x minus 2 is equal to 10 absolute values of x minus 15. This is absolute value quadratic equation. To solve this, we must write in standard form of quadratic equation. So this become minus 5 absolute values of x squared plus 2 times absolute values of x minus 10 absolute values of x minus 2 plus 15 is equal to 0. 2 absolute values of x minus 10 absolute values of x become minus 8 absolute values of x. Minus 2 plus 15 is plus 13. So this become minus 5 absolute values of x squared minus 8 absolute values of x plus 13 is equal to 0. Let us assign absolute values of x by t. So this becomes minus 5t squared minus 8t plus 13 is equal to 0. This is a quadratic equation. So to solve by factorization method, we need two numbers. The sum is minus 8 and the product is minus 5 times 30, which is equal to minus 65. So these two numbers are 5 and minus 13. Then insert in place of minus 8t this 5 and minus 30 as a coefficient of t. So minus 5t squared plus 5t minus 13t plus 13 is equal to 0. Then group these two and take out the common. The common for these two is minus 5t. What left? T minus 1. The common for these two are minus 13. So what left? T minus 1. Let's take out t minus 1 as a common. So what left? Minus 5t minus 13 is equal to 0. Either t minus 1 is equal to 0 or minus 5t minus 13 is equal to 0. So when we solve for t, we get t is equal to 1 or t is equal to minus 13 over 5 we get. Since we have assigned t by absolute values of x, so absolute values of x is equal to minus 13 over 5 has no solution because the output of absolute value can't be negative. Absolute values of x is equal to 1 implies x is equal to 1 or x is equal to minus 1. So the solution set is minus 1 and 1. This is all about solving advanced nested double, triple, quadratic absolute value equations. If there is any doubt, question, comment, don't hesitate to leave under comment section. If you enjoyed this video, I hope you get some value from it. Please hit the like, share, subscribe and bell button to get all notifications. Thank you so much for watching. I will see you with another video.